Okay, so conversions, this is convergence test for series. For a sequence, what is a sequence? Oh yeah. The sequence is a list of numbers, right? And if you want to find the limit of the sequence, they're not going to be as tough as the ones we did, but we'll let n go to infinity of a sub n and see if there's a limiting value. There might be, there might not be. So when you take the test, be careful that you read and see if it's a sequence they're asking about or if it's a series. Marcus, do you remember what a series is?
Yeah.
A sequence is just a list. It's the sum of the elements in a sequence. And I budgeted a lot of time for this because this is probably about, between this and the Taylor series, 40% of the exam, of the BC part of the exam. So you need to put your phone away and get a piece of paper out. Yeah, because 60% of the exam is AB. So 40% of the exam is BC.
All I have to do is 5%.
No, you want to get it. You get two scores. You get an AB score and you get a BC score. No, they don't. You get two scores. You get an AB score and you get a BC score. Okay.
But you're going for the AB score.
Okay. So we're going to talk about convergence tests for series. There aren't any for sequences. You just have to look at them and decide if they converge. Okay, so the first one, and the most important one of all, what has to be true for a series to converge? For a series to converge, the limit of the sequence has to do more than just exist. It has to be 0. So you're talking about summation of a sub n. And all of these are for positive terms until we learn what to do with the negative terms. But really, for any series, if the limit of this sequence is not 0, then it's going to diverge. What do we know if the limit's 0?
Nothing.
We know nothing. But it's a condition for us to decide if a series converges. So the very first thing you do is when you look at a series, you take the limit of the sequence, because if the limit of the sequence is not 0, you are done. You know it diverges. Let me write that. If not equal to 0, the series diverges. Does that make sense? That those n terms have to be getting smaller and smaller because you keep adding them in? And if you keep adding in 1, that's never going to converge. What's the next really important one? No, that's one of the last ones. But it's important. Do you remember geometric series?
Oh, the 1 over A minus n.
Yes, that's really, really important. And we will be doing some B problems out of the free response because there were some good ones. And that looks like this. It's the summation of AR to the n minus 1, provided you start at 1, to infinity. And with a geometric series, that's true. It's up to you. R is your common ratio. You have to recognize it. Now remember, if they ask you for what a series converges to, then it's geometric. You know it's geometric. So write out terms if you don't know what's happening. And A is your starting value.
Is it something where R has to be...
Yes, for it to converge. You don't have to know what the sum of the first n terms are, but the sum is equal to A over 1 minus R, 1 minus R, and absolute value of R has to be, what, do you remember? Less than 1. So that's what it's going to converge to. So what does this look like? If n is equal to 1, this looks like A plus A times R plus a times r squared plus a times r cubed, etc. To get from one term to the next, you multiply by r. That's that common ratio. So geometric series are the ones where they're going to ask you to find the value. So there's a little tip there. They may just ask if it converges or not, which is not much of a tip then. Then there was another one where we could find the value. You guys remember that one? Girls, you remember the other next one where we could actually find the value?
I can't believe there's 10 of these.
There's collapsing.
There's 10.
There's collapsing.
There's collapsing sums. Now, they're not going to ask you to rewrite this as a collapsing sum. It looks something like this. Well, hang on, let me write this first. And it's the summation of 1 over n squared minus 1. And when you see that, you recognize it's collapsing. You can find the value of that. But they usually won't ask you that. I don't ever remember them seeing that. There's a better way to see if that converges, and that's the fourth one. Hope I'm not going to miss anything.
What's that?
So what do we do with that? Do we just...
Isn't the collapsing sum also like the 1 over n?
1 over n plus 1. You had to do partial fractions to split that up. What? It's still a collapsing sum. Summation 1 over n minus 1. If you do the partial fractions and you figure out what it is, then you'll see it collapse. But I don't think they're going to ask you that. Instead, do we know if that series in item 3 is going to converge? And if so, how do we know? Do you remember this one? 1 over n to the p?
Oh, I love these.
It's the p series.
Serious. I know that one.
When does this converge?
Right there.
Not equal to 1, but greater than 1. Unfortunately, they never give us the p series outright. No, it'll be like 1 over n squared minus 1. Okay, so while we're doing this, let's talk about two special cases, or one special case. What about 1 over n? Remember what that's called? And you may use that. This diverges because p is not greater than 1. Didn't write that right, but anyway.
That's for the,
And that's the harmonic.
it doesn't convert
It does not converge.
the first sequence of what converges.
Right. Even though the limit of my sequence of 1 over n as n goes to infinity is 0. Remember, we know nothing. But if that hadn't been 0, we'd be in trouble. So what about,
Oh, wait, yes, so the first one if it is 0.
if it's 0, we know nothing. And the limit of this sequence, 1 over n squared, that also goes to 0. But does this converge or diverge? Converges, and you say by the p series.
Would you just say that?
Yeah. You could say this one diverges because it's harmonic. Everybody knows that. So we have to find a better way to do this. So we're going to go to 5. There's one I'm omitting at the moment, but I'll get it in there. What if you have the summation of 1 over n squared plus 1? I know that this one converges, right?
Oh, the comparison test.
And this one's smaller, 1 over n, no, I'm sorry. Yeah, 1 over n squared plus 1 is smaller than 1 over n squared. So since this bigger one converges, the one that's smaller than that will converge by the comparison test. The problem is you have to know if it's smaller or not. That's the problem. So, summation of b sub n converges when B sub n is smaller than A sub n and the summation of A sub n converges. And there are going to be some questions on the exam that will make you think about this statement. You'll see them. I've got them all in this one document. And I have them on a Word document, and I can post that. This is the printout of them. I can post it. But it's all the multiple choice questions that had to do with it. But it's a lot of pages. 19.
Wait, those are the...
I haven't made copies for you. I can, but you have them all if you know what the problems are. And you'll see them because I'll have segmented. But I can post it up on the web too. Or I can make copies. But these are all the multiple choice. Just convergence tests. And I'll put together, I'm going to do it separate. I'm going to do power series. They are Taylor polynomials, but there's some special things about power series. And then I'll do the Taylor polynomials. Just pull them out of the multiple choice. And then we can do the free response.
Over A even though you don't know anything?
Yes, summation of B sub n diverges. See if we can do this one. When B sub n is bigger than A sub n and summation of A sub n what? Diverges. I'm going to do multiple choice today. I'm going to try to get through all the multiple choice and then we'll do FRQs. So make sure you bring your packets. And next Monday I can't be here. I have a conflict for Monday. So it'll be study sessions tonight, tomorrow night, and then Tuesday, Wednesday, Thursday next week. May 9th. When is May 9th?
2 weeks from last.
2 weeks from today. It's a Wednesday. What if B sub n is greater than A sub n and A sub n converges?
We know
We know
nothing.
nothing.
Do it. Do it. Do it 2 weeks left. Do it.
YOLO.
YOLO.
More like no.
Miss G, tell him.
Miss G, you know what
No.
YOLO is?
What?
You know what YOLO is? Nope.
No, probably not.
Wow.
Okay. So what if we get in this situation with the comparison test? Do you remember the test that follows from that?
No, they did an integral or whatever.
Limit comparison test.
Yeah.
We will get to the integral test. Usually it comes in before this, but it doesn't matter. The integral test is most things you can't integrate, like factorials. So 6. We'll get them all. Limit comparison test. Now, do you remember that one? You might have to do this on the multiple choice. I don't think you'll have to do it on the free response. So convergence tests are pretty much just multiple choice. You'll have to use a little bit when you test endpoints on the ratio test, but not very much. Okay, so it's the limit. If the limit of B sub n over A sub n is equal to a number as n goes to infinity, then summation B sub n and the summation of A sub n, they do the same thing. They do the same thing. So you have to compare it to something you know. This is just my English. So if A sub n converges, then B sub n converges. So limit comparison is not bad. I use it when I can't use the comparison test. Now, multiple choice, I'm probably not going to go through all the details of this. I'm probably just going to take a good look at it and say, oh, I see what it's going to
To
do.
get a number, you get what?
You either get, you'd probably get infinity, in which case you know nothing. So it has to be a finite number, positive number. If,
If it's like 1.5, doesn't it be a whole number?
no, it just has to be a number. So if A sub n diverges, then B sub n diverges. I prefer to put my known series in the denominator. And I look to see what it looks like. You may have some problems with logs. You might have some problems with logs. You might have to do that. We'll do problems, so we'll find some of those. Okay. You ready? So, let's do the integral test. All of these are for positive terms. You will have, and I picked some improper integrals out, the series of b sub n converges if the integral from some constant to infinity, and I'll find a function that relates to b sub n. Remember, this is a sequence.
What, did your wheelchair get stuck on the shit?
Okay. B sub, guys, b sub n is a sequence, so we'll call it f of x. B sub n can be modeled by f of x. For instance, if I have the summation of 1 over n, my f of x would be 1 over x. Well, this only works if I can find a function that's continuous. Oh, it doesn't have to be continuous, but pretty much continuous. I have to find a nice function. I don't know how to do factorials. It has to mostly be continuous. Now, do you remember how to write that integral?
The limit.
Because if it's in the free response section and you don't write it correctly, you will not get the points.
The limit.
It's the limit, and we'll integrate from a to t, and t will go to infinity of f of x dx. And you might even have integration by parts on that. That's what we did Monday night, was integration by parts. Videos are up online. If I have time in class, I may hit on it again. If not, I won't, because the videos are there. We did a lot of problems, although I found some other nice ones.
It's under the in-here section.
Yeah. Okay, you guys? What if what? Okay, you guys?
Integral has to be equal.
It has to have a limit. Can't be undefined. If the integral has a limit. Pardon?
Let's say what number to start with.
Yes. It really doesn't matter what happens in the beginning. It's what happens when you get way out. Okay, you guys? The summation of b sub n will diverge if my integral from some number to infinity of f of x dx diverges. And if I were to integrate 1 over x, that diverges. Be careful. This is a different type of integral. There are two types of improper integrals. This is the one we're taking the limit as t goes to infinity. There's another one.
So it converges if the limit converges.
If the integral converges, the series converges. And vice versa. If you know that the series converges, the integral converges. Okay? This is the hardest stuff. Okay? Now, let's talk about the other type of integral while we're here. This would be, for example, if I wanted to integrate from 0 to 1 of 1 over x dx. Okay? That is not the same type of improper integral. Where is the problem with this one? At 0, right? I can't do 1 divided by 0. That's the area under the curve of 1 over x, which is right here, and it's this area to 1. And you can't use any of these tests for this type of improper integral. A number of people thought you could. You can't. I can even make it 1 over x squared. I don't know if that converges or not, but whatever. So you have to do the same thing here. We take the limit as t approaches 0 from the right side. So we're going to go from t to 1 of 1 over x dx. What's going to happen to this one? Is this going to converge? What's that antiderivative? Natural log of x. We're talking about positive numbers, so I do not need the absolute value from t to 1. And so it's the limit as t approaches 0 from the right, because log doesn't exist from the left, log of 1 minus the log of t. What happens to that? What's log of 1? Minus, and the log, remember what the log function looks like? You need to know what it looks like. What's the log doing? As t goes to 0 from the right side, this is going to negative infinity. So this is infinity, this diverges. So this is an improper integral, but of the other type. So the only ones that you can use all these convergence tests on are the ones that integrate from 1 to infinity. The other ones, where you have a vertical asymptote, it's not going to work. Some of you assumed on the test that it did, but it doesn't. Some of you tried to do the p-series test on these. You can't. P-series does not apply. It only applies going from 1 to infinity. And you'll see some in the examples I pulled up. Matt, did you have another question? No, any number to infinity. The point is that this is the type of limit from a to infinity. The other one is the limit. I don't have a limit there, sorry. Let me write that properly. Let me use it with limits. This type, from 1 to t, and t goes to infinity, that's related to the sequences and the series. This type is not. As t approaches some c value from, and it could be 1 or any letter a to c, where this is going to be a vertical asymptote. This is a horizontal asymptote, hopefully of 0 if it converges. This is a vertical asymptote, so it's a way different type. You actually have to do the problems. You have to integrate. So just don't assume. You can't use it for the other type of improper integrals. You can for the ones that go like this one. You can use p-series. Okay, so what was that? That was 7. Now that is all, those are all the all convergence tests for series with positive terms. But what if you have negative terms? Hopefully I'm not gonna- And there's 2 types. If you get negative terms, you can't use any of these tests. They don't work. So we have 8. Alternating series.
Value of
And this is the one you're going to use the most often. And it's going to look like summation, and it's negative 1 to the n, and then it's going to be some b sub n, as n goes from 1 to infinity. Watch your index when you try to set up the nth term. Make sure you check with your index that you're starting in the right place that matches the beginning of your series, because sometimes that gets tricky. And here's what you have to do for this. The series has to alternate in sign. Can't just be some negatives and some positives. Has to alternate. But even more important than that, what's got to be true about the limit of my sequence without the signs? It's got to be 0. So the very first convergence test, where is it? Right here. You always do that first. Always find the limit of the sequence. I don't care if it's positive or negative. It doesn't matter. If that sequence, just the positive terms, doesn't go to 0, you're done. Which is nice. Then I don't have to worry if it's alternating in sign. And the third thing is b sub n must decrease. Now I have a hard time, if not impossible, finding a series that the limit goes to 0 and the sequence itself doesn't decrease. And I know they do exist, and I could look it up in my answer books, but they're not going to do that to you. So it's safe to assume that the n plus 1 term is smaller than the nth term. Okay. And then there's something really special with our alternating series test. We can find the error. Do you remember the error? Okay, and this is what's going to happen on the free response. I'm just going to call it error. Okay, here's what we have. We have this summation of b sub n, negative 1 to the n. It has to alternate in sign. So even if it's a Taylor polynomial, and it alternates in sign, then I can use this alternating series estimation theorem, which is really nice, because it's easy. Let's write out this. Let's say we can add them all up. Okay, ready? That's S. And I'm going to have alternating signs, but I don't really care. But I'm going to have, let's just call it S1 plus S2 plus S3 plus S4 Okay? Let's say I take these first four. Is that equal to the actual value of the sum of the series? No. So if I subtract this is the remainder, r sub n. That's the sum of all the rest of the terms going on to infinity. If I take s minus, and we'll call that s sub n, the sum of the first n terms, and I'm going to put it in absolute value because I don't really care which side of that you're on, it doesn't matter, is equal to the remaining terms. Now, does that make sense? I may not know what the actual sum is. They may only ask me, what's the error if you do 4 terms? And to find the error of all these, adding all those up, is less than the first neglected term or discarded term. Yes, Margaret?
What is the most terms they ever have to go to?
Usually 3. They don't usually do too many. Don't go further than what they asked for. Don't say, oh, I'm going to prove that I'm really smart, because you're going to lose points. Do exactly, no, it's following directions.
So what would be the neglected?
So the first neglected term here would be S5. And that's what you, if you don't even know what to do, just go ahead and evaluate it for whatever they've given you, and the error will be less than that. Because all of these are getting small fast, but it's only for alternating series. Yeah. So if I had the alternate, now remember what this one is? That's the alternating harmonic series. Does it converge? Yes. And it converges because it's alternating in sign. The limit of 1 over n goes to 0, and 1 over n is decreasing. We recognize it. It's sufficient to say alternating harmonic series. Everybody knows it converges. So if I want to find, let's do a couple terms. The sum, let's do the first 4. So the first 4 is -1 to the first power. So it's 1, and then the sign's going to alternate, minus a half, plus a third, minus a fourth. Then all the other ones, what's the next term? 1/5. The difference between the actual sum of the series and adding up these first 4 terms will be smaller than 1/5. What's the next one after that? 1/6. See, these are getting small, so I'm not adding the decimals where I'm adding is getting further and further away from 0. Because this is what? 1/5 is 0.2. That's not very small, actually. What's 1/6? 0.1, 1/6, yeah. They're getting smaller and smaller. So that's all you have to do is evaluate the first term you don't use, and you'll see problems.
So what would the S be?
The sum of the first 4 is whatever that adds up to.
So it'd be S minus S.
So the actual sum minus the first 4, the difference between that is less than 1/5.
Wouldn't it be minus 1/6?
Yeah. I'm just looking at the value. You can see this is jumping up and down. Eventually it's going to go into the same thing. That's why that converges. Okay. What happens, now these are for negative terms still, but what happens if they're not alternating in sign? So example of things that don't alternate in sign would be the summation of the sine of n pi over n. I do have negative terms, but they're not alternating. And in this situation, I would write them out, because I don't know what it's going to do. And the problem with this is absolute convergence won't help me with this particularly, I don't think. Because what's the biggest this is going to be? 1. That's summation of 1 over n. And that's harmonic. So I really don't know if I can do anything. I can't compare. Remember, because these have negative terms in here. So if I do the absolute value of that, that's not going to help me either. I actually have to write the terms out. Not every test you do will work in every situation. That's the problem. So this is test 9, absolute convergence. And what it says, if, and this you have to read this correctly, the absolute value, let me write this properly. If I have the series of the absolute value of a sub n, n going from 1 to infinity, if this converges, if the absolute value converges, then the summation of a sub n with its negative signs will also converge. And the negative signs are just forcing this, it's going up and down, so it's kind of forcing it to converge a little bit quicker, so that should make sense. So if I have an example of this, let's do the summation of negative 1 to the n over n squared. N is equal to 1 to infinity. So if I want to see if that's absolutely convergence, I'll get rid of that negative 1 to the n, and I get 1 over n squared. Does this converge? Therefore, this converges. But I already knew that because it's alternating series. But what if I tried this one? We know this one converges. I know that converges. But is it absolutely convergent? Here's the absolute one. It's 1 over n. What's that called? That's a harmonic. So if the absolute value, here's the problem. If the absolute value of my sequence, or my series, doesn't converge, that doesn't tell me anything about this one, the one without the absolute value. It tells me nothing. All I know is that if the absolute value of the series converges, then the original series converges. That's all I know. But if the absolute value of the series diverges, I know nothing. I can write it if you want. So then,
1 over n converges.
no, diverges.
It's a harmonic.
Wait, I thought you said that.
You have to be careful how you do it. If the absolute value converges, then the original converges. If the absolute value does not converge, we know nothing. Because I do know that this one does converge. So just because you have a series that converges doesn't mean it's absolutely convergent. Okay? I know that's hard because you really have to think and keep it straight. If the absolute value, if the summation of absolute value diverges, then we know nothing about the original. It could, might not. I know nothing about summation of a sub n. The only way I know is that absolute value converges and the other one converges. And there's a beautiful test that we use. I can't do the integral test. I can't do the integral test on factorials. What's the other thing we have in there? Oh, our exponentials. So we have to have the ratio test. 10. Okay.
Everything classes out at the end.
It is. It's kind of fun. So what we do is we take the limit as n goes to infinity of the absolute value of a sub n plus 1 over a sub n. Three things that can happen. If this is less than 1, then my series a sub n is absolutely convergent. So if you have negative signs in there, no big deal. Remember, it's just stronger. If it's greater than 1, then my series is divergent. But if it's equal to 1, then we know nothing. And then what do you have to do? Because what happens at the endpoints? At the endpoints, this ratio is always 1 at the endpoints. So that's for the endpoints. You have to use the individual tests. So you must check the endpoints. Not a big deal on the multiple choice. You just get things wrong. That's all. 1 point. But on the free response, we don't check the endpoints. It's usually a lot of points. Endpoints using, you will, one of the first, yes, the first 9 tests. Actually, not even 9, I should say 8, because it's not absolutely convergent. So you substitute the endpoint in. This is when you have a variable in your series. And then you evaluate it, simplify it, and everything, and you'll end up getting one of these tests, usually a p-series or alternating series. Don't do that. Okay. That's it. You guys have everything?
Oh, gosh.
Took a while.
I've written these down like 10 times.
Got it.
So you should know.
I do them pretty well.
Well, that's why do you think I know
For
them now?
math, we do these too.
Oh, you do?
No, it's not weird.
No?
The math covers everything. So that's what I'm showing you guys.
Okay, you ready? You're going to take it next year, though.
No, I'm taking it this year.
They don't have it for the math test, do they?
Multivariable, yeah.
Oh,
Or
okay.
multivariable is what
Yes.
So like if the endpoints converge, then there's
They could, the endpoints might not converge at all. One might converge, the other one might not.
so then what? The series.
No, you'll find the, if you remember, you're going to find the radius of convergence. We'll do some.
Oh, and then it's like either equal to.
And then you'll find the interval of convergence. And now I'm trying to remember how I want to write this.
I was so close to it.
That was pretty close.
Like,
I'm thinking. Okay. I want to say one more thing. Hey, where's my problem? Okay, 2008, number 4. It hit you hard in the beginning. Now,
We got a test mystery?
yeah, I have to go get them, but you can work on a problem.
Okay, we'll work.
Well, I want one more thing here to say. So all the other error stuff you don't have to know. Yay!
They do it right away, too.
Oh yeah, it's in the power series where we get the radius of convergence. So we may not get to that. Okay, this is the ratio test.
It's time to work on it. Let's work on it.
Well,
I want to work on it this time. I have to work on it. How about you give us...
you need to work on this. This is your favorite part.
I do. I love it.
Remember, it's the limit as n goes to infinity, a sub n plus 1, a sub n. I want this to be less than 1 is what it tells me. Okay, so it's...
Wait, hold on.
I know, it's okay. I'm just seeing what I had to do. Some are worse than others.